Let's finish up our 7.3 Day 1 lesson. You'll need your calculator and you'd want to convert it to radian mode. Please make sure you do that before you watch the rest of the video. As we look at the unit circle, we know that not all answers are going to be one of those 16 unit circle friendly locations. We found that out with degrees, and now we'll do the same thing but with radians. We know on that right hand side, radians start at 0 and they end at 2 pi. So remember everybody, 2 pi is approximately 6.28. We're going to have decimals between 0 and 6.28 for our answers. You'll know that you're in radian mode when it gives you this restriction for theta. Solve for values between 0 and 2 pi. That will always indicate to be in radian mode. Now you'll still have the option of unit circle friendly answers, but we'll also have decimal approximations. And again, you want to isolate your trig term, take the inverse, and then figure out how to get that second solution. Let's try example D. 3 times cosecant theta equals -4. Well, notice we have a reciprocal function right here, cosecant theta. The first thing we want to do is get that by itself. Let's divide both sides by 3. And then we have cosecant theta equals -4/3. Like the part 1 video, anytime we had a reciprocal and we were able to isolate the term, a reciprocal function, we took the reciprocal. So the reciprocal of cosecant is sine. And that will be friendly to plug in on our calculator. On the other side, if we take the reciprocal of -4/3 is -3/4. To find the value for theta, -3/4 isn't one of our 16 y coordinate options. This means we need to type it in on our calculator by taking the inverse. And this is where you need to be particular. Your answer in radians will be different than what it would look like if you typed in degrees. We can't have a big number like 145.7 degrees because the radian only goes up to 6.28. Type in sine inverse of -3/4 on your calculator. Again, like a couple of our problems in the first video, we're actually going to get a negative answer. So this is going to be interesting as well. Our negative answer is -0.85. To make a radian coterminal, we're going to add 2 pi to that, which is 6.28. Therefore, the positive answer that would put you in that quadrant, -0.85 plus 2 pi, is 5.43. And that would be down in quadrant 4. The second answer, in radians for sine, we have to do pi minus our original angle. So this is all kinds of things you can plug right into your calculator. If we do pi minus the original angle, -0.85, because we take that answer up above, the two negatives just cancel out and make a positive. That would be pi, or 3.14, plus 0.85, which would give us approximately 3.99. I guess another thing I should have pointed out in the directions, did you see where it said nearest hundredth of a radian? Anytime we deal with radian answers, we go to the nearest hundredth, so I apologize for not stating that earlier. If you were confused about why we didn't go to the 10th, that would be why. All right, there's our first example, D. Let's try E. 2 times sine theta equals -2. At least we have sine this time. That's kind of nice. But we need to isolate the trig term. Let's divide both sides by 2. Like so. We have sine theta equals -2/2. We should put a little star on this problem, and hopefully you recognize -2/2. That's from the unit circle. It's one of our 16 specific locations. We need to find on the unit circle, in radian form, when sine, or the y-coordinate, equals -2/2. Well, sine's the y-coordinate, and it's negative in quadrants 3 and 4. Notice it's negative square root 2 over 2 at 5 pi over 4 and 7 pi over 4. There are those two solutions. So exact answers actually go a little bit faster than the decimal approximation ones. All right, let's try example F. Cosine theta minus 3 equals 2.36. To get cosine theta by itself, we're going to add 3. And we get cosine of theta equals 5.36. Well, that's not a decimal location or a location, since none of them are decimals actually. On our unit circle, that means we'll take the inverse. Go ahead and type that in on your calculator. I'll wait. Cosine inverse of 5.36. If you got an answer that said error or no solution, that would be correct. Remember, for cosine and sine, the furthest on the right you go is 1. The furthest on the left you go is -1. 5.36 is way bigger than the x-coordinate on the unit circle. Therefore, in that trig equation, no solution exists for theta. All right, last one. You're doing great, you guys. In radian form, what values for theta will 5 times tangent theta minus 2 equal 7? Well, we want to isolate our trig term, so we want to ultimately get tangent theta by itself. Order of operations, let's move the minus 2 over by adding it. Keeping that 5 out in front for now, 7 plus 2 is 9. To isolate the trig term, we're going to get rid of the 5. It's being multiplied to tangent. We'll divide to move it over. And now your tangent theta, your trig term, is isolated. 9/5 isn't one of our fractions on the unit circle, and it definitely wouldn't be a comparison of y divided by x for one of our 16 specific locations. This means we take the inverse. And tangent can be a number that's greater than 1, therefore we can take tan inverse of 9/5. Again, please enter that in and round your answer in radians to the nearest hundredth. You should get approximately 1.06. That's a positive answer, so that's valid. We'll take it. That's in quadrant 1. But tangent's also positive in quadrant 3. So our second possible answer is 180, or pi, plus that angle. And remember, you have all of those definitions on the first part of the notes for 7.3. Pi plus 1.06 is approximately 4.20. These are all the notes for solving equations where you just have one trig term to isolate, and you get one or two answers or possibly no solution.